Hi, Assalamualaikum. My name is Amiratul Huda binti Ahmad Fuad. Today I will present the microstrip patch antenna with higher bandwidth designed by using CST Microwave Studio. So we move to result and discussion. Here you can see the first table is given parameter, the second table is calculated value by using formula, the third table is parameter by using different substrate height, which is substrate height is equal to 0.75 and 0.95, and the fourth table is simulation result. This is the antenna design by using CST Microwave Studio. The left side is the microstrip patch antenna with the substrate height 0.75 mm and the right side is 0.95 mm. Both dimension is measured after the design is optimized. The first figure is S parameter should be less than -10 dB. The graph shows that the curve of the original antenna design and the improved design respectively by increasing the substrate height. The curve above shows that the red curve is lower than the green color. We can calculate the bandwidth by using the formula. The original antenna bandwidth is 0.5% and improved design bandwidth is 0.55%. The second figure shows the input impedance must be 50 ohms for two different substrate height. The width of microstrip antenna control the input impedance. The next figure is VSWR. The range of VSWR value is from 1 to infinity. The VSWR value under 2 is considered as suitable for most antenna applications, since for both two different of substrate height get the VSWR value does not exceed 2. This can be considered as good antenna design. The last figure is efficiency. The efficiency of an antenna is a ratio of the power delivered to the antenna relative to the power radiated from the antenna. A high efficiency antenna has most of the power present at the antenna's input radiated away. A low efficiency antenna has most of the power absorbed as losses within the antenna or reflected away due to impedance mismatch. Based on the figure above, are shown the efficiency for substrate height is equal to 0.75 is minus 3.6977, while for the substrate height is 0.95 is minus 2.9744. We can conclude that the increase the substrate height can improve the antenna design. Radiation is the term used to represent the emission or reception of wave front at the antenna, specifying its strength. Figure in the right side here represent the radiation of an antenna is its radiation pattern. Figure in the top left side here shows that far field 2D obtained from the simulation. It shows that the main lobe magnitude is at minus 4.02 dBi with its direction toward to 177 degree. The level of side lobe is minus 1.1 dB. Beam width is 33.6 degree. While in figure in the bottom left side are shown the main lobe magnitude is at minus 3.39 dBi with its direction toward to 90 degree. The level of side lobe is minus 1.6 dB. Beam width is 33.6 degree. Directivity is the measure of the concentration of and radiation of antenna's pattern in a particular direction. The higher the directivity, the more concentrated or focused is the beam radiated by an antenna. A higher directivity also means that the beam will travel further. Based on the figure in the top right side here, the directivity for 0.75 substrate height is 10.13 dBi, while figure in the bottom right side here for the 0.95 substrate height is 10.15 dB. We can conclude that the increase the substrate height can improve the antenna design. Antenna gain indicates how strong a signal an antenna can send or receive in a specified direction. Gain is calculated by comparing the measured power transmitted or received by the antenna in a specific direction to the power transmitted or received by a hypothetical ideal antenna in the same situation. Higher gain generally means that the signal is concentrated over a smaller beam width. This might be appropriate for some linear applications, such as those that need to isolate a specific signal and avoid external interfering signal. Figure in the top left side has shown here the gain is 4.412 dBi for 0.75 mm substrate height, while figure in the bottom left side shown here, the gain is 5.3 236 dBi for 0.95 mm substrate height. We can conclude that increased substrate height can improve the antenna design. And the last one is far field E for electric and B for magnetic field. Strength decrease as the distance from the source increase, resulting in an inverse square law for the radiated power intensity of electromagnetic radiation. By contrast, near field E and B strength decrease more rapidly with distance. The radiative field decreases by the inverse distance squared by reactive field by an inverse Q law, resulting in a dimension power in the part of the electric field by an inverse 4 power and 6 power respectively. The rapid drop in power contained in the near field ensures that effects due to the near field essentially vanish a few wavelengths away from the radiating part of the antenna. The CST Microwave Studio is the software that has been used for this project to simulate the antenna design by using the information given and also calculated by proof formula. Optimization is needed as per required. S parameter is less than 10 dB, Z impedance is 50 ohms, VSWR is more than 1.2 by adjusting the substrate width, substrate length, and also the feed line width. From the simulation above, S parameter, Z impedance, gain, directivity, efficiency, VSWR, far field, 2D and 3D pattern were obtained. The conclusion for this paper, by increasing the substrate height can improve the antenna design. The objective of this project was achieved by using the transmission line model, a rectangular microstrip antenna. Microstrip patch antenna was designed with higher bandwidth. On the other hand, other parameters also were improved, such as S parameter, Z impedance, gain, directivity, efficiency, and VSWR. It also gives a better understanding of design parameters of antenna. That's all from me. Thank you.